Hi and welcome to Energy Resources and Energy Transfer Lesson 4. So just a reminder, last time we looked at how heat can travel by convection. Okay, if you remember, we used the example of the tea light here. Okay, remember the hot air is expanding. Okay, it's taking up more space for the same number of particles. The cold air pushes the hot air up. Cold air takes its place, and we call this a convection current. So if you remember, we looked at lots of examples, from the magnet inside the Earth to hot gases rising from a nuclear explosion to kettles, etc. Okay, remember, a fluid refers to either a liquid or a gas. In science, we call those fluids. Okay, so today we're going to move on and look at another way that energy can transfer. Okay, and this is by conduction. Actually, I meant to bring a teaspoon up with me. Okay, let's pause it. So I'm going to okay, just run downstairs, get a teaspoon. Okay, so if you imagine if I was to hold the teaspoon in the flame, now this flame is not very hot, so this would take a long time. But you know, eventually the heat's going to travel along the spoon, and my hand that's holding the spoon is starting to get hot. And if the flame was hot enough, eventually it would hurt. Okay. Now this is not heat travelling by convection, okay, because the hot air is rising. So how does the heat travel along the spoon? Well, it travels along by a process we call conduction, okay. So the definition of temperature, really, the hotter things are, the more the particles vibrate. So when we start heating this end of the metal, the particles are vibrating more, and as they vibrate, they collide or bump into the particles next to them, which makes them vibrate. And of course, as they vibrate, they collide with the particles next to them, which make them vibrate. So the vibration passes along. And of course, if the particles are vibrating more, they're getting hotter. So in this case, heat is transferred from hot to cold via conduction, by particles vibrating and colliding with each other. Okay, when the video is finished, if you can come back and copy this slide, please. Okay, now metals are good conductors of heat. Okay, it's worthwhile to stop and think why that is. And there are actually two reasons. One is that obviously the atoms are close together, so when they vibrate, it's easy to pass on for them to collide and pass on that vibration. But also metals have free electrons, so the electrons, the outer electrons of the atom, can easily jump from atom to atom, and they can carry some thermal energy as well. Okay, so again, when this video is finished, if you can come back and copy this slide. So metals are good conductors of heat. Okay, now most gases, including air, are poor conductors of heat. So basically they're what we call insulators. Again, it's worth thinking why that is. Okay, and as you probably guess, it's because the particles are far apart. In general, in a gas, the particles are about 10 times further apart than they are in a solid. So it's very hard for the vibrations to be passed. Now, that is how clothes keep us warm. It's not the clothes themselves that keep us warm, but it's the air that's trapped inside the clothes, which is a bad conductor of heat. So a sweater or a jumper, as shown in the picture, it traps lots of air inside it. That air is an insulator, and it's that keeps you warm. Okay, and of course that's why animals have fur. You know, that fur traps a layer of air next to their skin. The air is a good insulator or a poor conductor of heat energy, which is how they keep cold. And of course, if they get really cold, they sort of fluff their fur up so it gets bigger. And that's why when we get cold, we get what we call goosebumps. Okay, so their hair follicles stand on end. It makes their sort of hair thicker on our body. It traps more air and it keeps us warm. Okay, so there is a worksheet to go with this lesson where you're going to look at various instances of conduction and insulation and things like that. I just want to talk a few things first, because there are a few cultural things in the worksheet that maybe specifically to do with the United Kingdom where I come from. Okay, so some of you may have been to a fish and chip shop in the UK. In fact, my parents had a fish and chip shop. I grew up living in a fish and chip shop. And the fish and chips, when you get them, are hot, obviously, and they're wrapped in paper. And normally the last layer, I think they still do this at home now, is newspaper. So they use clean paper to wrap the fish and chips up, and some grease paper, but then lots of newspaper. And that's to keep it warm, so that when you get hot, when you get home it's still warm. And it's to do with the trapped layers of air. It's not the newspaper that keeps the heat in, it's the trapped air. So just to explain culturally, fish and chips have traditionally come in newspaper. Okay, there's a mention in one of the questions about a string vest. Now, a string vest is exactly what you can see in the picture there. So it's a vest, it normally goes under your shirt, and it's full of holes. But that actually keeps you warmer than a vest that doesn't have holes. So I want you to think about how that works. And again, it's to do with, remember, it's not the clothes that keep you warm, it's the air that's trapped in them. I think there's one more. Oh no, that's it. Okay, so there's just a couple of things there to do with the worksheet. Okay. Now, the worksheet quite often says explain, so that means you're perhaps going to have to use at least a couple of sentences to explain what's going on. If you've got any problems with that, obviously message me, talk to me in the tutorial, or message me and show my homework. Okay, good luck.